Hello YouTube viewers, welcome to my channel S2T. In today's show, Rocket Monday, we're gonna talk about Leo Aerospace. So let's dive right into it. Well, first you have to understand the market that Leo Space is targeting. It's targeting SmallSat Market. Now there is a very exponential growth happening on right now, and there is even more potential in this exact market, SmallSat Market. And it has been classified as it's basically decentralizing space access itself. What does that mean? That simply means we went from NASA, Russia, China, India, and all that to any Tom, Dick, and Harry can access it. Even school, colleges, and all that, they are building satellites and launching it. So that's the whole point. Now, the biggest hurdle right now for in this industry is basically turnaround. Right now, there are many companies that build small sats. They actually call up. It's like, bro, tell me when you can launch. It's like, yeah, after 2 years. After that, they're gonna start building the satellites. Basically, the wait period before you actually start to make something and actually get it launched, it's very huge right now. Now, 2 years is acceptable for geostationary satellite, but something like CubeSat, which are made of normal shelf grade part, if you keep them in shelf for 2 years, they might not work at the other end. So people want this as quickly as possible, because these are inherently designed as either test bed, research grade stuff. So quick turnaround is very necessary for this. Another aspect is the satellites in orbit, they do not stay there for very long. That is why this market can grow this exponentially, simply because, again, if you take the band of low earth orbit, again, it's huge, but again, you do not want millions of satellites going there. And SpaceX, Blue Origin, and all that jazz, they are already putting thousands of that. So how the heck we can have even more put into it without destroying each other? Well, one benefit of the low earth orbit is basically it's very draggy. You cannot expect to put a satellite there and it's gonna last there. Some satellites drop off as early as a few months, and that's if they are lucky. If they're very well designed, 2 years maximum. So that's the whole point. So let's say you launched a satellite that is earth observation class. It's observing earth and it falls off. You want quickly replace it or upgrade it. So that is why everybody is looking into quick turnaround, and these are made of generally off the shelf parts. It's the solar cell is not some tri junction awesome grade solar cell. It's like normal buy off the market kind of cell. So we really want to shrink that turnaround time. Basically, we want to launch 4G phone when 4G is relative. We don't want to launch 4G phone when 5G phone is there. So what this company exactly is targeting? They are targeting low Earth orbit, obviously, and sun-synchronous orbit. Sun-synchronous orbit has exploded recently simply because that's the best way to observe Earth during daytime. Because if done correctly, what you're gonna have is basically you're looking down to Earth from satellite, and every place you are looking down has exact same clock. Basically, if you are looking down and it's 11 a.m., it's gonna be 11 a.m. and Earth is rotating. Next time you're gonna orbit, it's still gonna be 11 a.m. But let's say it would be in New Zealand, then it spins out again. It would be 11 o'clock in Australia. So you always get the same clock on the ground. So that's amazing. That is why, that's how all the photographs of basically Google Earth, basically that's how it's done. So sun synchronous orbit is very high demand. Now they are targeting lightweight protocols. They're not even going for small sat technically means anything below 500 kilogram. They are aiming something even lighter. They are directly aiming for CubeSat. They are not aiming for small sats, only CubeSats. So their weight capacity on low Earth orbit is around 57 kilograms to 25 kilograms for sun synchronous orbit. Now you may think, okay, that's a bit lightweight. Now that's absolutely true for any practical satellite. However, for CubeSats, that's more than enough. To give you a context of that, CubeSats have a standardized everything, basically their weight and volume. So using that standard, you can put 18 1U satellites, 9 2U satellites, they are not that popular, 3U very popular, 8 satellites, or 6U 4 satellites. 6Us are actually good because at that point you have enough space for actual telescopes and radio communication and all that jazz. Or sometimes you may want even bigger, which was used by NASA for Mars missions. You can use 6U, 4 of them. And if you want really big satellite, you can have 12U and you can send upwards of 2 of them. So it's quite a capable system for that. And let's say if you are familiar with satellite world records, India holds right now the biggest world record of launching more than 100 satellites. Hundreds of CubeSats were launched. Now any company that wants to launch that, they have to test it out. They cannot be like, okay, I built hundreds of them without testing it. They have to test it, then they're gonna upgrade it, fine tune it, and all that jazz. So this service provider can target that exact market. It's like, okay, you want to test your things out, we will allow you to test it. Now this is partially reusable because they are using high altitude launching. The high altitude launching is not done by basically weather balloon, balloon, they are using hot air balloon. So benefit of that is reusable. That aspect of it is 100% reusable, and it's fully mobile solution. Basically, you call them up, they bring the launch pad to you. You don't have to go anywhere. You don't have to book anything. You don't have to worry about range safety. They're like, I got this. So these specific targets they are aiming for, that Leo Aerospace. Now, what is their exact method? The exact method is hot air balloon. This is almost like balut, but balut goes much higher altitude wise. Balut can almost touch 20 to around 30 kilometers. This puppy at maximum can only reach 18 kilometer while carrying 3.5 ton total weight. So it does not go very high up. However, it does have the advantage. It can carry 3.5 tons. Most balut systems are much lighter weight than that, and or they are very huge. And because this hot air balloon, it's inherently reusable. So it's not like, okay, the balloon went up and poof. No, you can easily lift it off, land it down. And they have this platform. Now this platform is the burner unit, and it also has small thrusters, because once you are going through the atmosphere, you don't have to fight too much, because that's not your end goal. But once you have reached the final altitude, the winds are calmer at that point, but you still have to aim your damn thing. You cannot be like, okay, I'm supposed to go there, the rocket is pointing there, I'll just launch it. That cannot be done. So it has small thrusters built into that way it can finally orient itself. Like once it reaches the altitude where it's supposed to, it's gonna orient itself, and then it's gonna launch this multi-stage solid rocket, which is around 10 meters in height. And this is like 3 stage. 2 stages are solid rocket model. Third stage is just kick stage, just like, gonna fine tune the orbit, circularize the orbit and all that jazz. So this is their method. Take a hot air balloon, have a system, and it is 100% autonomous. There is no need for telemetry data. Like if telemetry breaks down, it has no problem with that. It's like, okay, the data will be put into hard drives rather than, like, directly broadcast it, but it will decide the you basically have to program it, and it's gonna take care of, like, the altitude, is it ready, the wind speeds and all that jazz. It's gonna do all those things on its own. So these are the method that they are aiming for. Now, what is their unique selling point? Because right now the small satellite market is very hot. Every Tom, Dick, and Harry is pouring money into it. So what are they offering that is so unique? Super quick turnaround is the main factor, because it's a hot air balloon launched, and the satellite, even basic satellite, I'm saying, the orbital rocket, solid rocket motor, it's not very powerful. Benefit, it's very easily mass producible. So they can just mass produce hundreds of these. That's the main aim for them. And the quick turnaround is simply because you don't need range safety or range itself. Even Electron rocket requires a range. India's PSLV, I'm saying, SLV also needs a launch pad. Only other Astra rocket, which is from DARPA, that they do not need. But again, they still have to build it. Like you can build it wherever you need to, but you still need 2 weeks. This puppy, just trailer truck. You don't have to open anything. Like the trailer itself will open up, and you can have a hot air balloon slowly rising from that. You don't need any ground structure for that. That really allows them to trim down their basically launch window. So launch pad comes to you. Basically, you call them up, they can come to you, and you can integrate the satellite, basically payload integration, right there in the container ship itself. And everything is self-contained. Now the ground station, basically you still want some telemetry and communication. That is also done in the basically truck itself. It's not designed for, like, okay, we're gonna have like this another ground station. No, everything is in that truck. And they can provide multiple service. The reason for that is, like, not every Tom, Dick, and Harry wants a orbiter system. There is a very huge demand for suborbital system, because let's say you want to build something and you want to test it out whether it's going to survive G-shocks of launch. You don't want to launch it in orbit, because then you can't recover it. But suborbital launch will introduce the same amounts of shock, same amounts of radiation of high altitudes and all that jazz, and ballistic trajectory make sure that it's gonna fall off without any issue. So suborbital is already a very big demanding industry, and sounding rockets have like a whole plethora of use of it. So this puppy can allow you to do that cheaply. Orbital rocket, again, that is normal thing. Gliders also, and drones and modular payload. So basically, many times, let's say NASA wants to test out this spectral graph, which gonna be used in next generation satellites. They have to test it out in high altitude first before they put it in on the satellite. They can provide very cheap system. Now again, NASA is unlikely that NASA is gonna use this, but you can understand that same thing can apply to SpaceX if they want to do it cheaply, or some another institute that is like, hey, we want to use this spectrum graph, but we have to find data from, let's say, 60,000 feet. These people will allow you to have the cheapest feasible option. So they have a tangible enough USP that they can stand in the market. However, the market has basically got hot, so to say. I started this YouTube around in 2018, and so far there are four competitors in the market, and I have covered all four of them. Basically, you have Electron Labs, Rocket Labs, Electron Rocket. You have Astra's Rocket 3.0, and you have India's SSLV, and China also has one of them in the workings, and again many more are already there, which I have not covered so far. So the launch market is very active. Every Tom, Dick and Harry wants that piece of that pie. So competitors are not only limited to national organization, they are also limited to private companies. So profit margin is very thin. Like think of this, mobile phones, every company wants to sell you the most expensive mobile phone. Why? Because that has the biggest profit margin. Basically, they sell you a $1,000 phone, they can make profit of $200. But what if they have to sell you a $200 phone? They can't make $200 profit. They only make, let's say, $20 or $10 sometimes. In case of some Chinese company, to control the Indian market, they literally sold it at zero profit. They were not selling it at loss, but zero profit. So this happens if you have a market which has way too many competitors. Every competitor's market, basically profit margin goes down very considerably. And now SpaceX is immune from that simply because there is no other alternative. If you want to launch, let's say, 10 tons or 20 tons flat out, there is no alternative. But small satellite market is getting hot. It's getting very serious. So if they really have to deliver on their promises in order to actually stay competitive enough, because Electron Rocket has already been launched, Astro Rocket would be launched once this pandemic is over. SSLV had the same thing. Basically, Electron Lab is already ready. These two other rockets would be ready the moment the pandemic is over. But other companies may also emerge randomly. So this is a very serious close race. So this was my presentation on Leo Aerospace. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.